Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're talking about adding fractions. And so the very first thing we're going to talk about is how to add fractions when they already have the same denominator, which is pretty simple. So here's the rule. Hey, this is on page 93 of your blue book. Fractions with equal denominators. To add or subtract fractions whose denominators are equal, the numerators are added or subtracted as indicated by the plus and minus signs, and the result is recorded over a single denominator. So they already had the same denominator to start with. We just keep that denominator. So let's see an example. Okay, you can see on the board here that I've written 1/5 plus 3/5. This is the example from your book. And according to the rules, we add the numerators together to get 4, and we keep the same denominator. But then I did it in pictures. Okay, 1/5 is 1 out of 5 parts, and I did this one in blue. And then 3/5 is 3 out of the 5 parts, and I did this one in pink. Okay, so then when I take the blue one, and I put it in the result down here, and then I take the 3 pink ones and I put them in, you can see that all together, 1, 2, 3, 4 out of the total 5 is the result. So I just put those all together into one, and 4/5 is the result. So what happens when we don't have common denominators? Well, then we're going to use what your book is calling the bottom-top rule. Bottom-top rule for fractions. Both the bottom and the top of a fraction can be multiplied or divided by the same non-zero number. They said same number except 0, without changing the value of the fraction. Well, that makes a lot of sense, because when we multiply both the top and the bottom by the same non-zero number, we're really multiplying by 1, because 5 over 5 is 1, and 100 over 100 is 1, and 1,000,000 over 1,000,000 is 1. So any number over itself is 1, except for 0. Okay, so when we multiply by, say, 2 over 2, we're really only multiplying by 1, and we know that multiplying by 1 changes nothing except the form that the number is in. So here is an example. I hope you can see my pretty orange here. But we started with 1/4, and then we want to add 1/2. Different denominators. So we're going to use our bottom-top rule. We copy the 1/4 down because he doesn't need to change. But then we think, okay, what does 1/2 need to be multiplied by? The denominator needs to be 4. So we need to multiply the 2 that's already there by another 2, which means we're going to choose our form of 1 to be 2 over 2. Now, when I multiply 1/2 by 2 over 2, then won't my new fraction become 2 over 4? So now the 1/4 got copied here, and the 2/4 is now here, and 1/4 plus 2/4, now we have the same denominator. We add across the top and get 3/4. Okay, in your book, you have a list of steps that we're going to use in adding and subtracting fractions. I changed the last step just a little bit. So let's look at each one. Find the least common denominator. We have to find out what is going to be the denominator that all of the other denominators will go into. Write all fractions with the new denominator. Find the new numerator that goes with each new fraction, because if we change the denominator, then we're going to have to multiply the same number that we did the bottom top to on the numerator also. So our fractions are all going to change. If they had to change to a new denominator, their numerators will change also. Add or subtract the numerators, and then put the result over the common denominator. So we are going to do some practices with that. Okay, so here is our example, and we're going to say, okay, what is the smallest number that both 11 and 5 will go into? and that is 55. So we're trying to get to the common denominator, 55. In order to get to the common denominator, I'm going to have to multiply this one and this one by a number that will get the denominator to 55. Well, we know that 11 times 5 is 55, so I'm going to multiply this side by 5 over 5, which is just 1, so it doesn't change anything. And 5 times 5 is 25, and 5 times 11 is 55, so that fraction is all ready to go. So then I come over here, and I have a 5, but I'm trying to get to a 55, so I need to multiply by 11 over 11. So I multiply by 11 divided by 11, which is 1, and doesn't change anything. Anything times 1 is the same number we started with. So now 1 times 11 is 11. 5 times 11 is 55. So now I have done what's called writing equivalent fractions. But notice that now I have a common denominator. So now that I have figured out what my least common multiple is going to be, least common denominator, I've multiplied each one of my fractions by 1 in some form to get the denominator to 55. I have corrected my numerators so that now they work with the new denominator. And now, last of all, I will subtract. 25 minus 11 is going to be 14, and I put it over the common denominator, and there is nothing that I can do to simplify that. That would be my answer. Oh, this one's a doozy, because when I look at 3, it's not too big a deal because 3 will go into 9 already. So I have to look at 9 and 4. And the smallest number that has both 9 and 4 is 36. Now remember, if you're not sure what that number is, 4 is 2 times 2. And 9 is 3 times 3. And there are no factors that they could share. Therefore, the smallest number that both of them will go into is 4 times 9, which is 36. So we're trying to head to 36 as our least common denominator, which means that this fraction, I'm going to get a different color here, this fraction we will multiply by what's missing. What's missing to take 4 to 36? Well, I need 9. So I'm going to multiply this one by 1, but the form of 1 will be 9 over 9. Okay, and that's going to give me down here 9 over 36. So I'm done with that fraction, and I don't need to mess with them anymore. So the next one is 5/9, but 9 is not 36. So I'm going to have to multiply this one. I'm going to move my plus sign a little closer. I'm going to multiply this one by what's missing. 9 times what is 36? Well, 9 times 4. So we're going to multiply by 1 in the form of 4 over 4. And 5 times 4 is 20. And 9 times 4 is 36. So I've gotten 2 of my 3 fractions over the correct denominator. And the last fraction is 2/3. How far does 3? What do I have to multiply 3 times what is 36? Or 36 divided by 3 is 12. So I'm going to multiply by 1, but the form of 1 is going to be 12 over 12. And 2 times 12 is 24. And 3 times 12 is the desired 36. So now I'm going to go back and put all my signs in. That was a plus, this was a plus, and now I'm ready to add because I have the same denominator and I've gotten the correct numerator that goes with each denominator, so that these 3 new fractions are equivalent to the 3 fractions I started with. So now I have 9 plus 20 is 29, and 29 plus 24 is going to be 53. 53 over 36. Remember, I keep this denominator, but 53 over 36 is not really the way that I should leave my final answer. Okay, so what do I do with 53 over 36? Well, 53 divides by 36 one whole time. Okay, so when I take the 36 away from the 53, I'm going to wind up with 17 left. 17/36. So 53 over 36 is 1 and 17 over 36. So now the answer to this problem is, instead of 53 over 36, we're going to finalize that with 1 and 17 over 36. And now we are ready to start your practices. Okay, here's our practice A. So copy it down on your board and then pause your video. All right, I hope you did that because I want you to work them on your own. But we're now going to look and say, okay, what do I need to multiply by to get a common denominator? What would my common denominator be? All right, so I'm going to look at 4 and 5. 5 is already prime. So the smallest denominator that I'm going to be able to go to is 20. I have to get to 20. So in order to take the 4 to 20, I need to multiply by 5 over 5. And in order to take the 5 to 20, I'm going to need to multiply by 4 over 4. So now I've got my forms of 1 that are going to make my denominator the same. So let's multiply 15 over 20 minus 8 over 20. And now that I have the same denominator, remember these are equivalent to the first fractions we had. So now 15 minus 8 is 7 over 20. And since the numerator is smaller than the denominator, there is no simplification needed for that one. So that was practice A. This is practice B, and I wrote it kind of spread out because I wanted to be able to multiply right on there. So copy it down and then pause your video. Okay, hopefully you did that. And now we're looking at 3 and 2 and 4. 3 is a prime number. 2, there's nothing that can go into 2, and 4 is 2 times 2. So 4 already includes the 2. 4 times 3 is 12. That's the smallest number that is going to include each factor. So we're going to put a 12 down here. That's what we're trying to go to. And we're going to multiply the 3 by 4, right? So 4 over 4 will give me the 12 that I want. And then over here, I've got a 2 in the denominator. I'm trying to get to a 12. So I'm going to multiply by 6 over 6. This makes it much easier if you know your multiplication facts. And then 1/4 needs to go to a 12 on the bottom. So I will multiply that one by a 3 over a 3. Okay, so now let's go. We have 20 over 12. And then plus 6 over 12 minus 3 over 12. And all of the denominators are the same. Therefore, I'm all ready to just add the numerators. 20 plus 6 is 26. Take away a 3 is a 23 over 12. The numerator is larger. Therefore, we're going to turn it into a mixed number. 23 divided by 12 is just one full time with 11 left over. So 1 and 11/12 is your final answer. Here's practice problem C. So copy it down and pause your video. Okay, so 2 goes into 8 and 4 goes into 8. So all we have to do is get everything over 8. Nothing needs to be done to this one at all. So we will just copy him down. He is ready to go. But we're going to have to multiply by 1 in the form. We want an 8 on the bottom, so we're going to multiply by 4 over 4, which is 1. And we're going to get minus 4 over 8. And lastly, we have a 1/4, but we need something over 8. So we will multiply this last one by 2 over 2 and wind up with 2/8. So now all I have to do is perform my operations on the numerator only, and then we will put our answer over the denominator. 5 take away 4 is 1, and 1 plus 2 is 3. So 3/8, final answer. Last practice problem. Copy it down and pause your video. Okay, on this one, we're going to have to change each denominator because 3 and 5 are both prime, and then we have 4 that does not have anything in common with the 3 and the 5. So we're going to have to say 15 times 4 is 60. So we're going to go to 60 as our new number, and 3 goes into 60 20 times. So we're going to multiply by 20 over 20, which is going to give us 40 over 60. And then we're going to multiply the 4 by 15, so 15 over 15, which gives us 45 over 60. And lastly, the 5, let's leave a little bit of room here. 5 goes into 60 12 times. So we'll multiply by 12 over 12, which means minus 12 over 60. So now that I have all of my denominators as 60, I perform the operation of math. 40 plus 45 is 85. Take away a 12 is 73 over 60. And 73 over 60 is going to be 1 13/60. So that should be the correct answer for that one. And we are done with this lesson. So lesson 32 is done and behind us. This is Mrs. A, and may God bless your day.